Thanks for joining me on today's Appgate demo series. Today's topic is the DNS forwarder and SaaS application access control. Let's jump into it. This is going to be a fun topic. Here's the scenario. A lot of companies are buying SaaS-based applications. No doubt, right? There's different types of SaaS-based applications, but think about Office 365, think about Salesforce.com, think about GitHub, and there's a myriad of other examples of these different SaaS applications. By my estimation, there's really two buckets that all these SaaS applications fit into. One is a bucket where the SaaS application has a definitive, defined, static endpoint, right? Think about if you're a developer and you sign up to use the MongoDB service out on the internet. MongoDB makes available their database service as a service. You can access it over the internet, and they're going to give you a specific URL to your instance of MongoDB. That specific URL will come attached with one or a very finite set of IP addresses that you can use to access it, oftentimes DNS names that are resolving to those IP addresses. But the point is, they don't change. If I were to set that service up and go travel around the world and connect to it from different places on the planet, I would always connect to the same IP addresses. So that's the static IP address concept in a SaaS-based application. Defining how you access those types of apps, pretty simple. To Appgate, that's just another destination. So you can define that as an entitlement using the public DNS names or the public IP addresses. Easy to do. Now, the second type of SaaS-based applications is something where, like Salesforce.com or Office 365, where as an end user, if I travel around the world and access the service, the IP address that the name resolves to will vary depending on where I am. So Office.com in California in the US may resolve to one IP address, but in Massachusetts may resolve to a completely different IP address. And that's because Microsoft has deployed global front-end technology that enables the end users to get a better result based on where they are. So they get a quicker connection, they get routed faster, they get onto the Microsoft network in a different way, depending on where they're coming from, right? And so those kinds of integrations are a little bit more challenging. But the point is that with Appgate, we have the ability to define both types of SaaS-based applications. Let's dive into one of the more complex use cases. The idea that as a user moves around, they would get different IP address resolutions. If you tie that into the Appgate world, the thing that you really need to start thinking about is if I want to use Appgate to control access to a SaaS-based app, I need to let Appgate define that resolution, that IP-based resolution. So how do I do that? In Appgate, we've created something called a DNS forwarder. And so the idea here is that I can configure SaaS-based applications to allow my users to have access to them. But when they try to access them, the DNS names that the app uses will actually be forwarded to the Appgate gateway they're connected to, and let that Appgate gateway go through the name resolution for them so that it's more pertinent to the location where the user is sitting. And then drive traffic from that gateway to that SaaS-based application. Let's dive into what this actually looks like in practice. So the first thing to think about is I have to be able to set my gateways up so that they're aware of this DNS forwarding concept. And so I do that in Appgate at the site level. So I come in, if I go look at, say, let's look at Azure, Iowa as an example. I've got, under my name resolution tab in the site, I've got a DNS forwarder configured. And all I simply did was I put the check in the checkbox. Appgate randomly generated this 100.127 IP address for me. Think of this as an IP address inside the Appgate gateways in that site that I can forward DNS requests to. From there, I need to define the actual DNS servers that I want that Appgate gateway to use to resolve any DNS names that it's asked to resolve. In this case, I've chosen two public DNS servers, but I could very easily use a private DNS service. I could use in the case of Amazon, Any of the .2 addresses on the VPC subnets effectively is a DNS service. So I could put my own VPC's .2 address in here as a DNS server for my Appgate gateways to use. There are all kinds of options in how you configure it and how you want these names to resolve. But the point is, the name will be resolved based on the request coming from the gateway instead of coming from the user. And so that treats the gateway contextually as the user of the SaaS-based application. And if the SaaS-based application will change those IP addresses based on the source of the request, then that source will be related to the gateway itself instead of the actual location of the end user. So now that I've defined that, the next thing that I have to do is go in. Let's copy this IP address so I can use it in a search string. Let's go in and actually search for that IP address. We can see a couple of different things. I'm going to search all categories. So the search results show several different search results that come back in different categories, including this Azure-only DNS settings. If I dig into the details here, you can see there are a lot of domain names that are pointing to that particular special DNS service running on that gateway in Azure, Iowa. msidentity.com, azureedge.net, and so on. These are all domains that are involved in actually authenticating to the Office 365 platform. And so what we've told Appgate to do is whenever a user sends a DNS request for any of these domains, forward those DNS requests to the 100.127.58.249, the special DNS forwarder that we have running in that environment. Now, if I back up another level and go back to my search results and change this to domain : then you can see there's some other interesting things that pop in here, right? So there's actually some entitlements for Microsoft Office 365 where I've got actions that are tied to those particular domains that are listed in the previous screen that I showed you. So here's domain : msidentity.com. And so the idea here is that I'm going to serve these entitlements down to the end user. And when my Appgate client sees this special domain nomenclature, it's actually going to establish a different entry in my local DNS settings. And the way on macOS to expose that is with SCUtil. And you can see here I've got some very special resolvers for individual domains that are defined. So I've got some internal ones that are related to my demo environment, but here's an example of one of those special resolvers, one of those special domains pointing to that 100.127 IP address. So that means that anything that I do on my local machine, if I try to resolve a name to box.com, then that name resolution attempt is going to be forwarded to my gateway at that 100.127 IP address, where that gateway is actually going to perform the resolution by using its configured domain services and pull that IP address and then send that IP address back down to my end user's device. And that's it in a nutshell, right? So this is how the DNS forwarder works. It's useful in identifying the specific IP addresses that a user needs to use to access an application that's out on the public internet somewhere, and that application might reside under many IP addresses, and those IP addresses could change based on location. Another interesting use case is the idea that the IP address that is actually in use is in use in several places. I can use the DNS forwarder to resolve it in different ways based on context and grant access to one or the other based on the context of the end user. So there's a lot of different use cases there. It's a very advanced feature and something that some of our biggest customers take advantage of every day. So thanks for joining me, and I look forward to hearing about some interesting results. Thank you.